Now for today's session, and before we starting, I'd like to ask whether we have the authors from the first our session. It was the paper titled Improving Accuracy by Ensuring Invariance in Two-Dimensional Binary Images in Intelligent Systems. Because we're missing this presentation, if the author are here, please
I'm here. The use of linguistic method of text processing, yeah?
No, it was the first our session and one presentation was missed, and we think that something was wrong with internet connection maybe, and authors can join us later. Okay, so let's follow our schedule, and the first presentation is the use of linguistic method of text processing for the individualization of the bank's financial service. So welcome.
I'm here. Thank you so much. 1 minute, please. Demonstrate it. 1 minute, please.
Don't worry. Before I start, I just remind for everybody that we have a time slot up to 15 minutes, like 10 minutes for the presentation and about 5 minutes for discussion.
Here. We don't see my presentation.
Not now.
1 minute, please. I'm sorry. Maybe I. Help me, please.
You can choose the window or you can choose screen you started to share. You choose and press the button to share.
Delete.
Like two actions, you choose the screen and then push the button.
I understand, yeah. But problem is document, yeah. One please. Maybe, yeah.
Yeah.
Yeah. Okay. Okay. Thank you.
So welcome.
Good afternoon, dear participants of the conference. I would like to thank the organizer for the opportunity to present the research, the use of linguistic method of text processing for the individualization of the bank's financial service. The author of the study, Хлібко Сергій, Внукова Наталія, Василь, Пивоваров Vyacheslav Avanesyan, and I, Davydenko Daria, today will be the main speaker. All participants had their opportunity to familiarize themselves with the presentation, so I don't want to spend a lot of time on the detailed review on the material. I consider it necessary to define the key aspects of the research. The main idea of the work is to demonstrate the possible interaction of the linguistics and banking through the use of morphological analysis for the personalization of card services in the bank. The database was formed based on the result of the preliminary analysis of the bank's CAS program. The morphological analysis was carried out according to the classic algorithm, which compares the combinations of criteria for the individualization of banking services. For example, not non-financial card product services and customer customization options. They carried out morphological analysis of the personalization of card services in the bank serves the purpose of banking activity in the matter of optimizing customer service and allows determining their priorities for the formations of the specific loyalty program. In addition, the study states that the result of morphological analysis can serve as input data for further processing by the decision-making system, decision-making helper. The automatization of the decision-making process in the presence of a preliminary morphological analysis makes it possible to quickly and more deploy studies the clients need in order to determine the priority component of card service personalization. Thank you for attention. It's all for me.
Okay, thank you very much. Anybody has any questions, please do not hesitate to ask the presenters. I'd like to ask you about what kind of methods of text processing you mean in your research.
In our paper, we used morphological analysis for personalization financial services. In process of research, we used, for example, Google Trends. We used morphological analysis main method, and decision-making helper for if you have used results morphological analysis, we used decision-making helper for making decision-making helpers. This is program for decision making opinion.
Okay, what kind of language do you use? For what languages you use results?
When we used morphological analysis, we two languages, Ukrainian and English. For example, in the Google Trends web application, so we have informed the request morphological analysis in Ukrainian and morphological analysis in English, the search frequency of word combination in Ukrainian and the word respectively is determined. Two languages.
Okay, thank you. Can you compare the results in Ukrainian and English, whether they are different or how much they difference actually?
In Ukraine, morphological analysis is more popular, but in English, morphological analysis have a result in America, in Canada. Popular also in each other country.
Okay, thank you very much. Anybody else? Okay, so thank you for the presentation and participation in our conference, and we go on the next presentation. It is a value approach to forming a fuzzy model for evaluation business models of IT enterprises in Ukraine.
Hello everyone. Just a second, I will share my presentation. Can you see it?
Yeah.
Yes. So once again, hello. My name is Nataliia, and this presentation is the findings of the research conducted by Olga in cooperation with Olena Levchenko and me. This study actually is devoted to the construction of a fuzzy logic model for evaluating business models of Ukrainian IT enterprises in terms of their value creation for recipients of digital services and products. The model is built using preliminary clustering of enterprises by the following indicators. First of all, the range of industry sectors and the range of services provided by enterprises. The average declared cost per hour, per labor hour for project implementation was chosen as the objective function. Groups of enterprises having similar parameters are formed, and their complex impact on the value of the objective function is analyzed. And last but not least, a fuzzy logic model for predicting the value of average cost of hour of labor for project implementation is built. So in order to identify some common features of groups of enterprises given the similarity of business model segments, which are considered to be characteristic features of enterprise value, it is proposed here to apply clustering methods and to calculate the number of clusters using the K-method or so-called elbow method, K-means yes or elbow method, and the method of simplified silhouette estimation. Such a combination is caused by the fact that often the input data is not clearly distributed along clusters, and as a result, the division obtained by using elbow method will not meet the highest quality assessment of the division. Clustering makes it possible to divide a set of objects into relatively homogeneous groups, into some n groups of elements that are most similar according to certain similarity criterion. And thus, so the elements included in different clusters should differ as much as possible. The next stage is the construction of a fuzzy knowledge base in order to build a mathematical model for establishing the relationship between input and output values. The formation of relations as a system of fuzzy logical statement is also carried out, and quantitative statistical values are translated into linguistic terms. So here on this slide, you can see the results of the distribution of IT enterprises in clusters due to the focus on the basis. Here you can see the distribution, yes, of the clustering, yes, by industry focus spectrum, according to the data in the personal profiles of IT companies in the clutch network, which we analyzed. Ukrainian IT companies, they provide services and create products for the, it jumps, provide products and create products and provide services for the following major industries. That is gaming, financial services, consumer product and services, information technology, business services, and others. And the data obtained on the spectrum of industry focus and the amount of dispersion were clustered. Yes, so figure 1 shows determining the number of clusters related to focus industry using elbow method, and in figure 2 we have determination of the number of clusters in relation to the focus industry by the silhouette method. And as a result of clustering, in terms of the focus, industry focus, we have revealed the following 5 groups or 5 clusters. Yes. Cluster 0 includes 68 companies with a very wide range of industries with an even distribution into 6-10 areas, such as financial services, information technology, medical business services, e-commerce. Cluster 1 includes 78 companies within a wide range of industry specialization in certain areas. It is not more than 40%. The main areas are financial services, business services, medical. So maybe I forgot to mention that in general, our set of analyzed indicators, yes, was over 225, yes. And then cluster 2 includes 50 companies with an average specialization of up to 60%, focusing on 3-5 positions in the following areas: financial services, medical, information, and others. And cluster 3 with narrowly focused companies with the highest concentration on 2-3 industries, in particular financial services, e-commerce, information technology. And the last one, cluster 4, companies that have very narrow range of industries, concentrating 90-100% of their customer base on one industry. That is e-commerce, information technology, financial services, gaming, and others. So then we move on to focus service clustering results. Yes, according to the data which we got from personal profiles of IT companies in the clutch network, Ukrainian IT companies, well, they provide the following types of services. You have named them here. So this is augmented virtual reality development, artificial intelligence, and so on and so forth. And clusters of enterprises based on the variance, the measure of dispersion of the services provided in percentage by type of service as follows. So cluster 0, companies that have a wide range of focus services from 5 to 16 services, with an emphasis on one of the services up to 50%, including custom software development, web development, mobile application development. Cluster 1, companies that have a fairly wide range of focus services with an emphasis on one of the following services up to 60%, including web development, custom software development, mobile application development, and others. Then cluster 2, companies specializing in the provision of 2-4 services with concentration of 85% on one of the following services, such as web development, custom software development, web design, and to more cluster 3 companies with high concentration of focus services, which is 90-100%, specializing in augmented and virtual reality development, application testing, artificial intelligence, mobile application development, and the last cluster, companies that are 100% focused on interface design. Then here on the slide, you can see a graphical representation of the clustering results in two-dimensional space by some type of services. And based on the clustering, yes, we grouped companies by similarity. Companies are considered to be similar if they are included in the same cluster by various parameters. As a result of this similarity grouping, we received 22 groups of companies, and there are, well, 3 of them have more than 20 companies in the group, 8 groups with 519 member companies, and 11 with up to 24 members. And the most numerous are the groups of enterprises that provide a wide range of services to a wide and very wide range of industries. So they belong to cluster 0 and cluster 1 in terms of industry focus, and cluster 0 and 1 in terms of focus service. A considerable number of enterprises provide the widest range of industries with narrowest range of services and vice versa. However, the most part of average declared cost per labor hour is higher for companies that provide a fairly wide range of services with predominant emphasis on artificial intelligence and other services given here. Clustering results allowed us to note certain regularities regarding the impact of combination of the range of services provided to the relevant industries. And well, this made it possible to formulate logical rules in a fuzzy model. And here you can see our calculations and formation of linguistic terms for input and output parameters and membership functions for fuzzy term series. So the linguistic terms were formed for the output value lower, average, high, and also we have below average and above average, and the values are, well, marked by U. By U we mark the range of provided services of corresponding types, and by V we indicate industry sectors for which services are provided. And here are well, the results visualized in the form of table. So a knowledge table was built on the basis of the obtained similarity groups based on the principle of belonging to the same clusters for both groups of clustered values. And all the blank cells here correspond to the value L that is low. A stands for average, H for high. In general, well, the author sees the prospects of further study of internal elements of business model aimed at ensuring the growth of the value of IT enterprises in Ukraine for external customers, as well as the study of external factors, in order to improve the fuzzy model in view of reducing the amount of necessary statistical information. Software implementation, testing of the model will allow making judgment to the construction of membership functions and rating coefficients. In general, in conclusion, we may say the following. So we used combined approach to assessing the value of IT enterprises in Ukraine, using cluster grouping, similarity grouping, and fuzzy interface. The highest paid services according to the study were artificial intelligence, business intelligence, and big data, consulting, e-commerce development, and others. These actually services can be provided only by specialists with high level of competence. The authors also revealed that it is inexpedient to widely diverse the range of services provided. It is optimal to focus on a limited number of services, especially such as custom software development, web development, artificial intelligence. And working with a wide range of industries or a narrower range of industries is not sufficient in terms of cost per hour, but it is worthwhile to give preference to such industries as financial services, medical, e-commerce, information technology, business services, and retail. And the end results allowed us to build a fuzzy logic model for predicting the average cost of labor hour for a project by particular enterprise. Thank you for your attention.
Thank you very much. Could you please clarify a little bit about the task you study? As I understand, the main idea is to cluster the IT enterprises.
Yes, so this study was devoted to the construction of fuzzy logic model for evaluating business models of Ukrainian IT enterprises in terms of their value creation for recipients of digital services and products. Mm-hmm. So we analyzed the data which we analyzed. It's a set of the indicators for over 200, as I remember, 255 enterprises regarding the range of services they provide and the range of industry sectors receiving services. Mm-hmm. And also the declared cost of hour of labor for project implementation.
And how you can suggest to use the results you obtain?
Well, we can use them, yes, to predict and to evaluate in general the state of IT industry, yes, what our IT companies, yes, deal with, what is, trendy now, let's say, in Ukraine, which specialists we need, what is still promising, yes, which areas are promising and need an investment maybe, and develop as well. Okay, in general, so it gives us a picture of our IT industry, what we deal with, yes, what services we provide to whom, yes, and what should be still developed.
Okay, thank you very much. Anybody else wants to ask a question or continue the discussion? Okay, let's move on our schedule. And I invited to present the paper onboard automatic control system parameters. Okay, welcome.
Good day. Do you see my presentation?
Yeah.
Thank you very much. Good afternoon. With your permission, I present a work. Neural network method for parametric adaptation helicopter's turboshaft engine on board automatic control system parameters. At present, electronic digital automatic control systems have been intensively introduced, which have higher accuracy and wide opportunities for optimizing of gas turbine engine controlling process. At the same time, much attention is paid to the development and research of intelligent algorithm for monitoring and diagnostics the operational status of gas turbine engine automatic control system using neural network technologies. At the same time, due to a number of reasons, closedness of works, narrow specialization of the task being solved, etc. Most publications lack theoretical and practical recommendation for solving the above problems, which leaves a wide field of activity for conducting scientific research in this direction. Currently, there are many research devoted to the development of automatic control system, but there are no works in the field of helicopter technology. This determines the relevance of the proposed research aimed at creating adaptive algorithm for monitoring helicopters' turboshaft engines, which make it possible to identify engine parameters with high accuracy under condition of external and internal interference. The helicopter's turboshaft engine closed on-board automatic control system was developed by this author's group and is shown in figure. Its modification consists in supplementing with modified software modules that implement adaptive control method. In this work, using as a basis the results of Ivan Bakhirev's research for a ground-based gas turbine plant, we consider the addition of the developed automatic control systems for helicopter's turboshaft engine with a reference of custom model module, a parametric adaptation module. This slide presents a mathematical model of the parametric adaptation task, which consists in determining the simplest similarity criterion. In the process of helicopter's turboshaft engine monitoring, the parameters of all elements of a closed loop change in real time. To ensure the desired behaviors, it is necessary to dynamically compensate the free turbine speed controller and replace it with a controller of the same structure tuned in the desired way. This figure is presenting a dynamic compensation diagram. The input data for training the neural network are the following parameters of helicopter's turboshaft engine, which are recorded on board the helicopter. For parametric adaptation, it is proposed to use PID neural regulators, which are an artificial neural network. The most common and simplest version for PID neural regulators shown in figure was chosen in this neural network architecture. And as an assessment of the work on helicopter's turboshaft engine, closed on-board automatic control system and integral criterion of the form is adopted. This table shows a neural network training algorithm developed on the basis of the Nelder-Mead method. The neural network of the perceptron architecture consists of two new neurons in the hidden layer. This number is due to preliminary studies that showed an acceptable quality of regulation with this architecture of the neural network. This slide showed the neural network training results. Results of adaptation criterion calculation and results of training algorithm are presented in this slide. It has been proven that the best version of the neural network in the cases of using the integral quadratic criterion in the neural network of the perceptron architecture with the sigmoid activation function of neurons. This slide and next slide show the results of primary and secondary tests of the developed method on 4 engine parameters: frequency of free turbine rotation, gas generator rotor RPM, matter regulator integrator, free turbine regulator integrator. The tables show the percentage improvement with the adaptive controller compared to the standard controller. The results of comparative analysis are present in this slide. It has been proven that the use of parametric tuning units with a customizable or reference model in helicopters' turboshaft engines closed on-board automatic control system improve the quality of recognition of transit process by an average of 30% compared to the use of standard regulators. The conclusions are presented on this slide. Thanks for attention. Thank you very much.
Thank you for your presentation. Are there any questions for our speaker? So could you please clarify a little bit according to the results you're experimenting? What kind of experiment it was where you estimate the errors and compare neural architecture with others?
Thank you. The error for neural network training do not 1%, and we calculation modulation characteristic model, convergent model, and we research for transit process, and we compare algorithm for training neural network training, the back propagation method, quick propagation methods, and other training methods, algorithm and methods for training neural network.
And what was the data for training? How many data you have for training your model?
We used next data and fragment of training sample during the operation of these parameters: gas generator rotor, RPM free turbine rotor, speed gas turbine in front of the compressor turbine. We make a clustering result, initial experiment sample and training sample. We calculation and see what C2 Fisher-Pearson.
How many items in your training set?
Training set is 256.
Okay, I see. Thank you.
Thank you. Thank you.
Thank you. Anybody else? Okay, let's go to the next paper. And it is welcomed the paper titled Reflex Systems of Natural Language Processing in Educational Management Information Systems.
Good evening, dear colleagues. My name is Pirogov Kirill, and I'm here to present to you the presentation named Reflex Systems of Natural Language Processing in Educational Management Informational Systems. So, can you see the presentation?
Not now. Yeah, we see.
So, let's start. So a characteristic feature of today is the intensively developing and implemented informatization processes in almost all spheres of human activity. They led to the formation of a new information infrastructure, which is associated with a new type of social relations and the use of information and communication technologies. It is proposed to take the theory of information interaction, non-force theory of information interaction, as a scientific and methodological basis for solving this task. Within the framework of this theory, not only the apparatus for forecasting the development of systems based on the interaction of people was created, but also the mathematical apparatus for the informalization of the soft component, also generated by human activity, was provided. The purpose of the work is to create, using the mathematical apparatus of the theory of non-force interaction, models, methods, and means of formalizing natural language information, on the basis of which it would be possible to create economically profitable, effective, simple, and competitive ICT systems for the management of the quality of education and educational management. This work is dedicated to the development of such a reflexive intellectual system. So, education management information systems enable officials to be constantly informed when developing the foundation of state education policy and to make final decisions based on reliable information. Considering this, the requirements for the formation of educational databases are very high, because poor quality educational information can have far-reaching negative consequences, including the adoption of incorrect management decisions regarding the distribution of limited resources. In view of the above, the development of data information systems and their integration should be the basis of state management of the educational system. Today, in addition to managing the development of complex systems, the theory is also used to manage enterprises, programs, and projects, to build decision-making training systems, diagnose cardiovascular diseases, in voice control systems for technical devices, and others. That is why, by applying the mathematical apparatus of the theory of non-force interaction in the management of the soft components, it is possible to achieve the set goal. That is, it will be possible to obtain formal numerical models that will make it possible to make accurate forecasts about the result of informational influence and distribute information about the management of the quality of education to its addresses. So the effectiveness of the construction of means of automatic management of the quality of education largely depends on linguistic means of describing objects and management processes. Therefore, the adaptability and mobility of the languages of communication with the computer, the non-procedural character of the description of objects and management processes, and the use of context and silencing are indispensable conditions for the rational construction of linguistic means. These requirements have a contradictory nature due to the orientation towards non-professional users on the one hand and limited possibilities on the other. The resolution of this contradiction is related to two things. The first one is with the division of incoming information flows into those that are formalized and accordingly require traditional dialogue software tools for the processing, and those that are difficult to formalize require significant cost for formalization. And the second one is using the result obtained in the theory of non-force interaction for the construction of natural language information processing tools. In order to build effective information and communication systems and technologies for the management of the quality of education, according to the authors, it is necessary to carry out the following preparatory work: to study the object and situation in which the processing of natural language information is carried out, choose a strategy, tactics, and means of processing natural language information, determine the most influential forms of information presentation, and develop models and methods of their formation with the help of all available means of presenting, proving the information, and to develop a system for analyzing the effectiveness of information provided and its correction in case of insufficient action. So here you can see the experiment that was taken to solve this problem. They based on the informational redundancy of natural language, and there was divided the input text into clusters, among which there will usually be those that determine the reaction required under the given conditions. So here you can see more experiments, more formulas that was measure of non-force action. So here is the results. So the reflex method directly calculates the response of the intellectual systems adequate to the input influences. And on the figure 1, you can see the scheme for calculating the amount of influence in reflex intelligence systems. On these schemes, you can see the calculation of the certainty of reactions in the project relative to the effects to text clusters. So here you can see the calculation of the additional probabilities that input text clusters bring to the intelligence systems, and calculation of the total impact on decision-making managers or specialists who perform managerial actions. And on this slide, you can see the calculation of the new certainty of decisions or actions in the management of the quality of education and the selection of the most definite decision. So this is this scheme is scheme of information flows in the reflex system of natural language information processes, and on the basis of the proposed model, one of the options for application of the reflex system of natural language information processing has been developed in this scheme. So the next is discussion. During the processing of input information, the system's natural language communication tools will be used for identification of the algorithm for solving the problem discussed in natural language text, definition of the object and subjects of management, setting a time interval, formal representation of the parameters of the problem to be solved, presentation of components of education quality management in the information base, and with the help of the system, it is planned to solve a number of problems. Here they are. The first one is formalization of the natural language text or its part. The second one is selection of the necessary information from the database on the information and communication systems of education quality management and its presentation in a user-friendly form. The third one is making changes to the information representation of components in the database, in particular parameters of works, risks, costs, executors, responsible, etc. And the system will implement 3 forms of interaction with the user. The first one is text that is presented in the information base or obtained from external sources, for example, from the internet, the user's input, which is typed on the keyboard, and the user appeal in oral language. At the heart of the system is a reflex model of behavior in the operating environment, which is ambitiously interpreted and will contain a set of programs that provide an interface between the user, the information base, means of filling the information base, the information retrieval systems, and in the education quality management systems. So, and for the conclusion, it will be in the process of the study, it was shown that the mathematical apparatus of the theory of non-force interaction is quite simple and convenient for building natural language text processing systems. The used mathematical apparatus will be the basis of the systems of discrete processing of the semantics of the text in the management of the quality of education and educational management. In further work, it is planned to develop the structure and algorithms of the specified system and conduct its experimental verification and production conditions for the management of educational processes. The use of the development new ICT will affect the development of the formed ICT environment, which is dynamic and open, which will allow to improve the process of management of educational institutions, improve and maximally direct their activities to increase the quality of education. The proposed model differs from the existing ones by identifying differences in the conditional probabilities of the appearance of message addresses at the amount of informational influence of fragments of natural language text, which made it possible to automatically determine the most likely addresses of this text. The developed technology meets the requirements for simplicity, it's informative and easy to understand, and is minimally expensive. Its foundation is based on the models and methods of influence processes management developed by the author, and the obtained results bring our state closer and closer to the creation of competitive ICT for the management of the quality of education and educational management, and bring us closer to the creation of full-fledged artificial intelligence. Currently, reflex intellectual systems solve various problems in the areas of human intellectual activity already today that it was said above. Thank you for your attention.
Thank you very much for your presentation. Are there any questions? Yes, please.
Okay, hello, Mykola. Could you specify? Is this do you describe a kind of interface which is going to be developed in your research? And if yes, what kind of resources you are going to turn to or to combine this interface with? Thank you. No interface. It is just like a theory, and in further work, there will be some development of the interface based on the system that was provided in this work. Okay, so you mean that your system will contain some resources also, because it was stated like you say that you're going to deal with a rather wide sphere of problems and rather wide field of application. So how would you deal with the resources in all those fields? Are you going to include them into your program, into your project, so to say, or you're going to somehow interact with this? And I mean interface, not about these buttons we're seeing on the screen, but something which helps a person to interact, some system which helps a person to interact with some resources which are situated actually far away and cannot be connected so easily.
Yeah, I understood the question. So the first one is just a project, not a program. The second one is the resources that are needed. They will be in the further work. So this theory is just on the stage of the development, and so in the further work, it will need some resources. Yeah, you're right.
Okay, thank you.
Thank you.
Anybody else? Yes, please.
Good afternoon. Do you hear me?
Yeah.
Yeah.
Good afternoon. I can hear you.
Okay. I have a question. Could you explain us? You had a term on the figure, non-forceful action. Please, could you explain what does it mean in real life?
Excuse me, can you please repeat the question because I can hear it?
Non-forceful action. There was a term on the figure in the middle of your presentation.
Yeah.
So what does this term mean in real life? What kind of action do you mean in this term, in this notion?
Okay, I understood your question. Is maybe the theory of non-force information interaction, but it's the theory in ICT systems, and it was used like the methodological base and scientific base for our research. So it's used in ICT systems.
Mm-hmm. And non-forceful action, what kind of action?
It's interaction.
Mm-hmm. So, and it is non-forceful. What does it mean, non-forceful, in this case?
Excuse me, could you please one more time repeat the question because I can hear it.
The action is non-forceful.
Yeah, yeah.
What does it mean, this notion, non-forceful? In real life condition, I mean.
In real life, I could not say some examples to you because as I know, this theory is used in ICT systems, so I can't answer to your question.
Okay, maybe your publication will clear up this. Thank you.
Thank you. Thank you for the question.
Thank you. Thank you. And please, another question. Yaroslav? The hand up and you're muted. Okay, no question as I understand. So thank you very much for presentation and discussion. And we have the last presentation for today. It is dendritic artificial immune network model for computing.
Good afternoon. I'm glad to welcome you to this conference. At the Kharkiv University of Radio Electronics, we conduct research in the field of the development and application of artificial immune system. Our report is devoted to this topic. I give the floor for the report to the employee of the Department of Computer and Intelligent Technologies and System, Matveyev. Please attention.
Hello everyone, can you see my screen?
Yes.
Okay, let's start then. Your attention is invited to a report on the topic of dendritic artificial immune network model for computing. This work was carried out by employees of the Kharkiv National University of Radio Electronics. This paper presents the results of constructing a dendritic artificial immune network model using graph theory. The content of the work is given on this slide. The theory of artificial immune systems is one of the directions in the organization of artificial intelligence systems. To date, there are several common artificial immune system models shown on this slide, which are used to solve various practical problems. First, it's negate positive selection model. Second, clonal selection model, and third, artificial immune network model. These models differ from each other in the way of editing the antibody population, ways of organizing immune operations, and the possibilities of integration between immune objects. Among the immune models, the most promising for particular application is the immune network model, since it involves organizing the interaction not only of antibody and antigen populations, but also the interaction of antibodies within the same population. Existing models of immune networks have a number of disadvantages, the main of which are low speed and relativity. Relatively low accuracy, which manifests itself, for example, in solving problems of classification, clustering, and pattern recognition. In accordance with this, the paper sets the task on constructing a three-type immune network model that will allow solving the problem of increasing performance, ensuring acceptable accuracy of the results, and reducing the complexity of the process of forming a network of the antibodies and recognition errors. We will consider the construction of a three-structure of immune network using the example of solving the problem of data clustering. In theory of artificial immune systems, the concept of affinity is used to measure that determines the strength of the connection of similarity between the antibodies of the artificial immune network, where D is the Euclidean or Manhattan distance between the features of the itis and the G's commune objects. As the criterion that creates the number of affinity bonds between antibodies, the natural affinity threshold value is used, which is the average affinity between all antibodies in the population. It is proposed to form a K-connected graph of antibodies. The process of forming the tree-like structure of the immune network is multi-stage. At the first stage, the antibody network is formed as graph, where each vertex is connected to all other verticals of this graph. The process of forming a network of antibodies is a process of optimizing the fully connected graph of objects, the verticals of which are antibodies, and the edges are the affinities between them. Optimization refers to the reduction of the number of bonds between antibodies of which the NAT is used. Reduction of the number of connections between antibodies occurs due to removal of connections characterized by minimum values of affinities. Each antibody can create no more than K links with other antibodies in the other network. Other links are removed. This area is borrowed from the classification algorithm K nearest neighbors. This slide shows a dendritic K-connected network of antibodies with parameter K equals 3, which can vary in the range from 2 to many connections. Thus, by reducing the number of connections between antibodies in the network from the initial graph with complete connections between objects, and the structure of the antibody network is formed, in which cluster centers are sequentially selected. At the second stage, after the formation of K-connected network of antibodies, the level of stimulation of each antibody is calculated based on its affinity with other immune objects forming the network. Based on the value of the level of antibody stimulation, the candidates for the centers of the clusters are determined, which are shown on this slide, with white verticals and dark gray outline. From all the candidate antibodies, the antibody characterized by the maximum number of connections with other antibodies of the network and the maximum level of stimulation is selected to the center of the clusters. The objects selected as the center of the formed clusters are marked in green. It should be noted that in this case, the formation of two clusters is expected in the clustering process. At the first stage, after the distribution of the centers of the clusters, the process of determining the affiliation of the antibodies of the immune network is to them takes place. First, immune objects are clustered, which are characterized by a strong affinity connection with antibodies, which are the centers of the clusters. Next, to carry out clustering of other antibodies, the affinities to each of the clusters and its antibodies are determined. The definition of avidity is based on the affinity between immune objects. And reflects the level of strength of the immune connection between the objects of the cluster and the antibody. Cluster centers antibodies are marked in green. Antibodies associated with two different cluster centers are marked in blue and yellow, and the rest of the antibodies shown in light gray. On this slide, clustering of the other objects occurs by triggering immune process in tree-like immune network of antibodies, thanks to the operation of cloning, mutation, and use of suppression of clones and the network of antibodies that do not belong to any cluster. This slide shows the result of artificial immune tree network clustering of antibodies distributed between two defined clusters. Thus, the process of object clustering based on the DNet immune model can be represented as a sequence of following stages shown in this slide. It's setting the clustering parameters and obtaining the initial set of objects, determination of the scales of characteristics of the studied objects, formation of K-linked dendritic immune network, selection of cluster centers, determination of cluster identities, immune self-regulation of the network, conclusion about the clustering of objects. Accordingly, at the level of immune operations, the DNet method is represented by the implementation of the relevant stages presented on this slide, namely the stage of preparation for clustering, the stage aimed at the formation of K-connected immune network, and the stage of network integration. A comparative analysis of proposed clustering method with other data grouping methods, C-means and MST, are existing immune models, Quank and INET, was performed on 3 sets of objects. When comparing two main metrics for use, time that's spent by the clustering algorithm on grounding objects and is the accuracy of clustering. The results of the comparison are shown on this slide. Showed that the C-means algorithm is characterized by the maximum accuracy of object grouping, and the clone algorithm was the most performance. The MST method is characterized by the best speed, but is significantly inferior to other methods in terms of grouping accuracy. The proposed DNet method is characterized by high accuracy of data grouping. It outperforms the C-means method in terms of speed, but it inferior only to the MST method in terms of indicator. The DNet method outperforms the other immune methods both in terms of speed and object grouping accuracy. That makes this method the most adapted to the organization of creation based on immune approach. Conclusion. The existing models of artificial immune networks have a number of disadvantages, the main of which are low speed and relatively low accuracy. To increase the speed, ensure accepted accuracy of the results, the reduce of the complexity of the antibody network formation process is new IIS model has been proposed in the form of DNet and dendritic artificial immune network, which is built using graph theory. The formation of the dendritic structure of the immune network is considered in the example of solving an object clustering problem. It is proposed to the form of a K-connected graph antibodies, in which the strength of the connection between the antibodies in the immune network is determined by the affinity of antibodies. Based on the value of level of stimulation of antibodies, the center of clusters are determined, and the determination belongs to clusters of other antibodies of the immune network is based on the values of the affinities to each of the clusters. The DNet model is represented at the level of immune operations by the sequential execution stages of preparation, formation or K-linked immune network and network integration of antibodies. Experimental stages of the DNet immune model were carried out and compared with existing immune models and other clustering models, which showed that the DNet model is superior to other immune models, both in terms of speed and accuracy of the grouping of objects. Thank you for your attention.
Thank you very much for your presentation. I'd like to clarify the issue about practical implementation of your results. Could you please clarify for what kind of practical task the method you describe will be?
So it can be used to spread the work. We are talking about clusters, and when we're talking about clusters, it is of network clusters. We need to make they perform faster, because the way they work, they need to send the messages between them and then perform the tasks that they are needed to do. So using our system, we can clearly make this interaction faster and spreading the tasks that can be spread in the cluster, made by them faster, so the work that they need to done is better, I think.
Okay, thank you. Do you estimate the limitation of the method?
Limitations, I think limitations are the how fast our working machines interact within our cluster. Because if we have a lot of machines, a lot of computers that need to be calculate something, the time that needed to interact between the different parts of different base clusters can be really long, but this is a drawback of any clustering method.
Okay, thank you. Are there any questions or comments? Okay, thank you very much. Before we close the session for today, I'd like to ask whether we have the authors of the paper improving accuracy by ensuring invariance of two-dimensional binary images in intelligent systems. I mean Rahim Mamadov, Elena Rahimova, and Gurban Mamadov. So this paper is not presented today. Maybe it is some technical reasons for the authors. We have some sessions tomorrow. Unfortunately, we don't see presentation for today, but all others presentation were successful. So thank you very much for all of you for working today. And see you tomorrow in our workshop according to our program. Have a nice evening and see you tomorrow.
Thank you. Bye-bye. Have a nice evening
Bye-bye.
too.
Thank you.